Hey everybody, today we're talking about permutations and counting. And so today we're going to learn how to use permutations as arrangements. And we're also going to be using the counting principle to count permutations and factorial notation. All right, so a lot to learn. Here we go. A permutation versus a combination. A permutation, the order matters. And I'll show you what I mean in a moment. And I'm going to try to help you remember that with just a dumb way. I'm going to say order patterns. It'll help you connect that the order matters with permutation. Combinations, the order doesn't matter. All right, and they have this formula here, which I'll show you how to use in a minute. But if you're taking notes, you should pause the video, and this is the part where you should write that down. The ACT, for example, expects people to know how to do this in their head, and therefore they can use variables in the problems. That means the calculator, even though I'm going to show you how to use that, would not be something that would help you if there was variables in the problem. All right, so we need to know how to use these formulas, and I'll show you how to do that in a second. So permutations are where we are taking things in order, and the order matters, okay? And combinations can be used when we're just choosing a group, like, for instance, no, you three, would you help me clean up after school? It doesn't really matter what order they're in. They're just those three people. All right. The permutation, it would be more like, Bob, you're president, and Jim, you're vice president. And that matters, right? I mean, who's president? The order matters. So we'll talk more about that in a second. All right, so I want to do a permutation out and show you how this formula would be used in a combination. So this is really the meat of what I'm trying to teach you today. So let's say that you have three people to pick from: Bob, Sally, and Mick. Okay, and if I'm choosing out two of them, bet you didn't know I was going to pick Sally and Mick. All right, so I could pick any combination of two. Get it? Combination. That's this one. If I'd have said that the order mattered, okay, and I was going to have these three race across the parking lot, all right, and then first and second place will be awarded, then I would have used a permutation. All right, so my three people, Bob, Sally, and Mick, if I wanted to do the permutation first, that's where the order matters, then I could say it's Bob, then Sally, or Sally and then Bob. It could be Sally and then Mick, or Mick and then Sally, or it could have been Bob and then Mick, or Mick and then Bob. And that's a total of 6. And is that all of them? Well, let's see. Our formula for finding permutations is that you're supposed to do the bigger number, the n, which is we have 3 people to choose from, and this would be 3p2. I have 3 to choose from, and I was finding how many permutations there were of 2 people. All right, and I'll show you how we would use this formula right here to do that. I'd do 3 factorial over 3 minus 2 factorial. That's the same as 1 factorial. And 3 factorial, in case you've never seen that exclamation mark before, that means 3 times 2 times 1. And 3 minus 2 is 1 factorial. 1 factorial is just 1. Okay, so there's supposed to be 6 answers for this, and look at that. Here's my 6 answers. Final answer down here, 6. There were 6 permutations. And again, a permutation, the order matters. Now, what if I was doing combinations? Okay, if I'm doing a combination, then it doesn't really matter if I say Bob and Sally, you're my pick. Well, then it doesn't matter if it's Sally Bob or Bob and Sally. Okay, so the order, therefore, doesn't matter in that kind. Well, let's see what the formula would yield for this. It's 3C2, C for combinations, as opposed to the other one was permutations. And this is going to be 3 factorial over the same exact thing 3 minus 2 factorial with an extra one of these. I like to say it just a dumb way to help you remember it. See, there's an extra one of these. Whatever number is right there, there's an extra one of those on the bottom. All right, so then this becomes 3 factorial, which is 3 times 2 times 1, over 3 minus 2 factorial, and that's just 1, times 2 factorial, which is 2 times 1. All right, look at how those cancel so nicely. I could have said, multiplied it all the way out and then simplified it, but it's so much easier to just cancel them. And then 3 divided by 1 is 3. Notice there's less combinations than the permutations. Why? Because the order mattered over here, and that doubled it because we had to do them each twice. All right, so my combinations, 3. My permutations, 6. All right, let's see if you really understood that. We're going to just do one more, and I'm going to ask you to try this one. This is off the script, but I think it'd be very valuable for you to try this right now. Let's have you try 4C2. Now, if you didn't take notes, you should go back and take those notes because you need to know what the formula is for doing combinations or permutations. All right, I'm going to ask you to pause for a second and then try it and then come back. Okay, so you should have done 4 factorial over 4 minus 2 factorial, which is 2 factorial. And then see there's an extra one of those, 2 factorial. That's the same as 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Well, all of that multiplies out to 4, so why don't I just cancel that 4 right there? And then the final answer is 6. If I have 4 things that I'm choosing out 2, then I can do that in 6 different ways. Okay, now I need to show you how to do that with a calculator. Actually, let's do one more by hand here. How many permutations are possible? Let's do this by hand. Permutations is the P one. And I have 3 letters, and it doesn't say how many I'm going to choose. All right, so I'm going to choose to take out all 3. I'm going to have 3 things, and I'm going to take out 3. This is how many you have. This is like the possible, okay? And this is how many you want to take. All right, so if it's 3P3, that means I have 3 things, and I want to take out all 3 things, but this is important, the order matters. So ABC is one of the possible orders of those 3 things, or BCA, or CBA, or ACB, or BAC, or CAB. Now I feel like there's 6, but what would I do? I would use one of my formulas. Hopefully you've taken notes on this now, and you can know it was 3 factorial over 3 minus 3 factorial. And a lot of people are going to go, what does that mean? 0 factorial is defined as equal to 1 because obviously we don't want to divide by 0. And obviously we know the answer isn't undefined. There is a number. I think it's 6. Let's find out. Oh, it's 3 times 2 times 1 over 1, which is 6. Excellent. How many combinations? Well, let's just go right to the formula. Combinations, I'd have 3C3. This is how many I have. This is how many I want to choose. And if the order doesn't matter and I've got these 3 things and I'm going to choose all 3 of them, then there's only one way to do that. Let's prove it with the formula. It's 3 factorial over 3 minus 3 factorial, which again is 0 factorial, which is defined as 1. And then there's an extra one of these. See, there's an extra one of these. 3 factorial on the bottom. So that's really 3 times 2 times 1 over 1 times 3 times 2 times 1. Everything cancels. It's equal to 1. And like I said, there's only one way to do it. All right, now I know some of you guys are going to want to use a calculator for this, and if you've got a graphing calculator, you should see which kind you have. You'll be able to tell by the time we're done with this practice one here. If you have the new version, it'll look kind of like the blue one on the right when we're done to do 3p2. And if you don't have one of the new ones, then it's going to kind of look like this middle one when we're done. All right, so the first step is you put in the 3. Okay, if we're going to do 3p2, we put in the 3 on your calculator. Then you have to hit the math button, which is this one, and that'll pop up this menu here, and we're going to choose the probability, and notice I arrowed down to this because it's got the p in it. All right, so I've already typed in the 3, and then I hit NPR, and then I put in the 2, and then I hit enter, and the calculator says 6. We did it by hand. The answer was 6. See how the calculator can do it too? So if you do the same exact set of buttons on the newer calculator, it'll look like this. It's got what I call pretty print. And that's a mode in your calculator that if you've got the newest software, you can choose that mode to make it have subscripts and things like that. So, all right, so that works for whether you got your old calculator or the new calculator. You hit math, you go to probability, and you choose either the P or the C depending on what you want. All right, let's move on. So the counting principle. This one is super simple. If Judy has 4 different shirts and 3 different pairs of pants that all match, how many different outfits can she make? You could use a tree diagram, but honestly, it is so painful to have to draw all of those possibilities. And these 3 shirts and these 3 shirts, there were 4 pairs of, 4 shirts and 3 different pairs of pants. And if I had to take the time to label all that, it would drive me crazy. And you know what happens? We end up with how many branches? Take a guess. 4 times 3 is 12. So all you got to do is multiply. So when it comes to choices, this is a theme we're going to use this whole unit, is you multiply your choices. So that means there is 12 possible outfits. Okay, I could make a detailed list here, but again, I've showed you how tedious that would be. You just have to multiply them. Simplest part of our whole test. All right, moving on. So again, same scenario here, 3 different pairs of pants, 2 different pairs of shoes, 2 necklaces, and 1 pair of earrings. How many different outfits? Well, now you're going to just choose one of each. Now, if this problem had said you could choose 2 different pairs of pants, like you were going to layer them or something, it could get a lot more complicated. But unless it's complicated like that, you just have to multiply them. I've got 4 shirts, 3 pairs of pants, 2 pairs of shoes, 2 necklaces, and 1 pair of earrings. You just multiply them all out, and that's your answer. So this is 12 times 2 is 24 times 2 is 48. 48. No, you don't have to draw a tree diagram. That's crazy. It takes forever. All right. Now, there's one last kind of problem, and there's a lot of this on the homework, so pay attention. Permutations can also be done using a method called blanks, and it is so much easier to do them this way when the problems are complicated. If they're simple, like there's 7 people running a race and there's 2 people that are going to be awarded medals, it's just 7p2, and you put it in a calculator and it's done, or you use the formula. But when the problems are more complicated, think about using blanks. Okay, how many different license plates are possible, assuming 3 letters followed by 3 numbers? So I'm going to make a blank for each of these things. And remember me saying you multiply your choices? Okay, and how many choices are there for the letters? Okay, well, if there's 26 letters in the alphabet, then you have 26 choices. Assuming for a moment that you can repeat the letters, which you can, I've seen it on the license plates before, then 26 times 26. If you couldn't repeat, you'd say 26 times 25 times 24. Okay, but if we can repeat, it's going to go like this. And then 3 numbers. The 3 numbers, well, they each have 9 choices. No, think about it. Couldn't you have a 0 plus 1, 2, 3, 4, 5, 6, 7, 8, and 9? So that's 10 choices, and 10 choices, and 10 choices. Again, if we're talking about allowing things to not repeat, then you're going to have 26 times 25 times 24 and 10 times 9 times 8. Why is there less choices here? Because we already used up one of the numbers right there. Okay, so you just have to multiply these out. Again, this is pretty calculator intensive, so you have to know what to do. You have to write it out and then use the calculator to multiply it all out. Notice we haven't been doing much probability yet. It's pretty much just been how many different ways. So to make this into a probability, you might say, what was the probability that this was your license plate? Well, there's only one of those, right? That's in that exact order. And how many were there? We just figured it out. Assuming that that there was no repeats, it would have been this, which would be a slightly smaller number. Or assuming things could repeat, it would be this, which would be this massive number of license plates that are possible, and it's only one like this, so it'd be 1 out of whatever this answer was. All right. Sorry to be going so fast, but you're going to have some time to talk about this with your teacher in class too. All right, so example. I've got Greg, Sam, and Tyler, and then there's 2 girls that are also going to be competing in a race. How many different ways can the 5 racers place? This assumes they're all racing at the same time, okay? And then I've got 5 racers, and then if it's a race, it's a P because the order matters. Order matters. Trying to connect mattering with permutation. All right. And it says they're going to award first, second, and third place. That means that's how many we care about in their finishes. Like we don't care about the 4th and the 5th place. We're not going to keep track of that. So it's 5P3. Now, could I have used blanks for this? Yep, I could. Let me show you. This one, let's finish it off. It would be 5 factorial over, and I know some of you are grabbing your calculator already. Absolutely, you can use the calculator, but it'd be good to know the formula too. 5 minus 3 factorial. So that's 5 times 4 times 3 times 2 times 1 over 5 minus 3 is 2 factorial, so that's 2 times 1. These will cancel. 5 times 4 is 20, times 3 is 60. And a calculator could have done that for you too. But let me show you how you could have also done this with blanks. Remember me talking about the blanks before, and you always multiply your choices? How many different choices were there for that first place? 5 people could have got first place. But after that first person has been chosen, how many are left that could have been in second place? 4. And how many would be left for this spot? How many choices do I have? 3, because the other 2 spots have, the other two people have already been used in the first 2 spots. So 5 times 4 times 3, and look at that, it's the same exact answer. All right, so you can use blanks or you can use permutations. All right, so now if they say that a girl needs to finish first and third, like you heard, on the radio that girls won first and third place in this race, well then I'd make blanks for sure. I'm not even sure how you would do this with a permutation without blanks. All right, so I'm going to use the blanks. In first place, it has to be a girl. But do I know which girl? Nope. So if there's 2 girls to choose from, that's how many choices I had for first place. And now third place, because I already chose one of the girls for this spot, there's only 1 left. Okay, because there's only 2 girls in the problem. So then I'm going to put a 1 here. And the rest of the spots are boys. How many choices did I have for the boys? There were 3 of them. So 3 times 2 times 1. So this is 2 times 3 is 6, times 2 is 12. Final answer, 12. What is the probability that a boy finishes second? Probability now that a boy finishes second. All right, well, how many ways are there that a boy could finish second? Okay, and that's if second place is the one that matters. We're really focusing on second place, right? And a boy finishing second place, how many boys are there? Well, there's 3. So there could be 3 different ways to do this. Okay? There are 3 different ways that a boy could finish second. Okay? So then there's 3 out of how many different ways could they have finished? We already got that. 60. See that from up here. So the hard part is figuring out this top number, but what it's out of, that's just a permutation. So 3 out of 60. All right. Example 3. You and 7 other swimmers are competing in a race. How many different possible ways can the swimmers place first, second, and third? I'm going to just do this the easy way. There's you and 7 others. Careful, that's 8 people. And a race, that means the order matters. P. 3 spots. I'm going to only pay attention to the 3 that I pick out. Okay? And 8P3 is my answer. I'd use a calculator to get that. Now, could I have done it with blanks? Yep. I have 3 blanks. How many choices for that first spot? 8. How many choices for the second spot? 7. And the third spot? 6. 8 times 7 times 6. And 8P3 is going to be 8 factorial over 8 minus 3 is 5 factorial. And if you think about it, 8, 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1. That's what those factorials mean. It would be 8 times 7 times 6 either way. All right. But this time I'm going to need to use blanks because it says this condition here. It's like a conditional probability. If you finish in second. Well, if you finished in second, how many choices do I have for first, second, and third place? Only 1 choice. Think about it. First place, there's a lot of people that could have got first, but you got second, so there's only 1 choice for that. Okay? How many choices were there for the first one? There wasn't even 8 because you were for sure here, so there was 7 choices for that. You've used up 2 choices by now, so then 7 leads us left with, after 2 choices, come out of the 8 people. Think server. Oh, there you go. 6. All right. So there's 6 choices for this last spot because 2 spots had been used up already, or 2 people had been used up already. So 7 times 1 is 7. 7 times 6 is 42. And last but not least, what is the probability that you finish in third place if you finished in the top 3? Oh, this is rough. All right, so if you finish in third place, okay, I looked at how long this video is. We don't have time to talk this through, and honestly, for our first day, there's no way you can be expected to go that far. So I'm going to get you right on to a couple of zip code questions, and then we are done, and you're doing your homework. So how many different 5-digit zip codes are possible? Well, 2, 3, 4, 5 spots, and there's 10 different numbers. Now, in the real world, we don't actually have all the different numbers for the start of the zip codes, but we're assuming for a moment that you can use any number. So this is 10 times, and can they repeat? Absolutely. I mean, the zip code in Minnetonka is 55345, so it repeats. So 10 times 10 times 10 times 10 times 10. All right. What's the probability that the first 2 digits of a zip code are 5? All right. So if the first 2 digits of the zip code are 5, then there's only 1 choice for that first spot. It's a 5. And there's only 1 choice for the next spot. It's a 5. But then there's a lot of other things that could happen here. We've got 10 choices for those last 3 spots. 10, 10, and 10. Okay, out of how many were possible? That was this one. Okay, so this is 10, 100, 1,000, 10,000, 100,000 from up here. Okay, and there's our answer. It's what we want over what's possible. How many zip codes are there if you could only use each digit once? All right, well, then if there's 5 spots in the zip code and I can only use them once I had 5 choices for this, I wouldn't have 5 choices for the next one. I'd only have 4, and then 3, and then 2, and then there's only 1 choice left because if they can't repeat. All right, same idea on this last question for trying to keep the video short enough. We're going to let that one go, and have a wonderful day. Your homework is the Permutations and Counting worksheet.